Hello, detectives. It's Justin again, and welcome to your mission. Today, we're investigating mysterious expressions that are hiding behind secret identities. We'll need to use our math skills to match up each expression with its equivalent expression, disguise. To help us reveal the secret identities of these expressions, we'll use the distributive property and combine like terms to identify and create equivalent algebraic expressions. To get started, make sure you've done the warm-up at the beginning of your guided notes. If you haven't, pause here and come back when you're done. All right, let's get into it. Let's start by going over the warm-up and making sure we've got the distributive property down. In the warm-up, you investigated the distributive property to discover that it applies to expressions that include variables. We can distribute or multiply the term outside the parentheses to each term on the inside to write an equivalent expression, even if we don't know the exact value of every term. Here's the first practice problem. 2 times the quantity m plus 7. This expression is representing twice the sum of m and 7. We can see that we have 2 m's altogether, and 7 repeated twice is 14. Distributing the 2 to the terms in the parentheses would give us 2 times n plus 2 times 7. We know that multiplication between a number and a variable is represented by attaching the 2 terms, giving us 2m. And 2 times 7 is 14. These expressions are equivalent because in both forms there are 2 m's plus 14. On to the rest of the warm-up. After distributing the 5 in the second expression and simplifying, we get 20 plus 5p. And distributing the 8 in the third expression gives us 8y plus 8. Great job using the distributive property. We now have one tool we can use to see past the secret identities. But we're not there yet. Next up is combining like terms. Here's our first example. 3x plus 6 plus 2x. Which terms would you say are alike? Yeah, 3x and 2x are alike because they're both x terms. The number attached to the variable x is called a coefficient. 2 terms are considered alike as long as they use the same variable, no matter what their coefficients are. The 6 is just a number without an x, so it counts as a different type of term called a constant, which means it does not have a variable at all. We can make this expression simpler by putting all those x's together. How many x's would we have? 5 x's, or 5x. Remember that repeated addition is the same as multiplication, so adding 5 x's is the same as 5 times x. The equivalent expression is 5x plus 6. Let's try another example. 4 plus 7g plus 5 plus g. It looks more complicated because it has more terms, but we've totally got this. Which terms are alike? Yep, 7g is like g, and 4 is like 5. So we'll be combining numbers with numbers and g's with g's. 4 plus 5 is 9, so let's write that down. In order to add the g terms together, we have to think back to what we've learned about the identity property. We could write out a single g as 1g, which indicates 1 times g. But what would 1 times g be equal to, no matter the value of g? Right, just g, because the identity property states that multiplying something by 1 doesn't change its value. Whenever you see a variable by itself, there's an invisible coefficient of 1 attached to it. So Now we know we'll be adding 7g plus 1 more g, giving us 8g in total. The simplified and equivalent expression is 9 plus 8g. Is there another way we could write this equivalent expression? There is. We could also say 8g plus 9 because the commutative property states that the order in which terms are added doesn't impact the value of the expression. Now that we're pros at combining like terms, we have the tools we need to reveal the most complex secret identities, those that use both distribution and combining like terms at the same time. Pause here to read through this example in your guided notes. Then put your math detective skills to work by uncovering the secret identities of these 3 expressions. Feel free to go back and use your notes and examples on each separate skill to support you in putting them together. Check your answers starting with the first expression. As we saw in the example, we'll start by distributing the 3 to 6 and r inside of the parentheses using multiplication. That will give us 18 plus 3r, and we bring down the plus 4r. Is that the final secret identity of this expression? Not yet. We still need to combine like terms. Which terms will we combine? Exactly, 3r and 4r. Adding those together gives us 7r, making the final equivalent expression 18 plus 7r. In the second expression, we'll start by distributing the 5 to the b and the 2, even though it's not listed first in the expression. Why do you think that is? It all comes back to the order of operations. We have to multiply before we can add. That will give us 5b plus 10, but we can't forget about the first 5b and the plus sign. Combining the like terms, 5b and 5b, will lead us to the final equivalent expression, 10b plus 10. Last but not least, the third expression, starting with distribution, gives us 2y plus 4. And then we bring down the 10 with the plus sign. This time, the like terms we have to combine are the numbers, not the variables. That gets us 14 plus 2y. Another case closed. Thanks to the distributive property, combining like terms, and your sharp minds, we've revealed the secret identities of all 3 expressions. Don't forget to complete the practice activities that go with this lesson, and I'll see you next time. Hey, hey.